think this should be good. I need to study more, so I'm gonna live stream this process. I don't know if anyone's in this chat, but we're gonna be doing some complex analysis. I have some sample problems here. Excuse the setup, but we can get the stream in the other tab. We can barely hear you. Let's see. Let me turn this up. Is that better? Let me go into settings here. Is that better? I think people are actually here. That's cool. Let me adjust some things on my side here so this is actually legible. Is that better? Anyone in the chat? See some heart reactions. That's cool. Let me hear it on my end, actually. My iPad is on full blast. I'm turning it up a bit more so the audio levels are like in the green on my end, so that's good. But we can adjust that. Cool. Okay. Without further ado, let's start. I think we can adjust even this so that that's a bit bigger. So I can actually see what we're doing. Okay, I think there's like 2 other people here. I don't know. Whatever. Anyone here do complex analysis? That's cool. Let's see here. That's what I was afraid of because I don't have good noise cancellation now. There's gonna be a lot of like background noise. So I have a fan going. Okay, I'm just gonna start now. I'm just gonna write problems addendum. I got a review guide on another monitor here. So we got Cauchy-Riemann equations for a function. So let's say that we got f of, say, f is a function from C to C that maps x plus I y going to u x y plus an imaginary part I v x y. Then let's see, f apologies, I'm also a bit sick, so that's going to be an issue. F has a derivative at z naught equals x naught plus I y naught. I think Cauchy-Riemann equations are going to be, there's some conditions about the continuity of the derivatives as well. So the Cauchy-Riemann equations are ux, then one of these is a minus. I just always assume that one of these has a like a negative sign as the bottom one. The question is, what's like the necessary and sufficient conditions here? I don't want to look back at my notes, but I think it's sufficient enough that all the partials are continuous or something. Like if ux, uy, vx, vy all continuous and exist at xy excuse me, at xy equals x naught, y naught, and these two hold, cross that out, then f has a derivative at c naught equals x naught plus I, y naught. Typically we only like look at those two. Let me actually refer back to my notes. Because I think this is a sufficient formulation, but this might be like the weaker formulation. I can open that. Because sometimes you don't have them continuous or something. You only have like the derivative exists or something. Let's see here. Oh wait, no, I actually got it. I think this is the exact statement. Like, if they all are continuous, or they exist in an epsilon neighborhood around xy equals x naught, y naught, and these equations hold ux equals vy, uy equals vx, then the derivative exists, and yeah, okay, cool. Okay, that's cool. That is basically where all of complex analysis comes from, which is why we can do things in complex analysis. Now, this is a question. Let f, it's going to be annoying, but I don't know if that's visible, but let f be entire, which just means it has a derivative on all of the complex plane, and not constant. Then it's asking which of the following functions are also entire. So f z bar, f z bar, or f z bar bar. Oh, hello. Quitch math, I think that's it. How you say it? Okay, cool. Any takers in the chat? Excuse me, I have a freaking cold. Not fun. Can we get a 1, 2, or 3 in chat? Yeah, what? 2 people in chat. So, I think it's gonna be. It still has to obey the Cauchy-Riemann relations, right? So, it's gonna be something like. My instinct tells me this guy, because you have to swap twice to make it good, but I want to show that. So like, let's say f is entire and not constant. So for any x plus I, well, okay, that's not showing up, is it? I could do this instead. Like, assume we have x plus iy, right? F x plus iy equals u excuse me. Let's see here. This is f of z. That's a terrible z. We have f of z bar. This is going to be fx minus iy. U of x minus iy plus iv. X minus y, I guess. X minus y. So that guy? Because you're just substituting in that. F z bar as a whole. You're just swapping these two. I don't think that will work. But I think if you do the bar inside, then that should work, because what you're doing is you're doing the bar here and you're doing x minus iy. That should be excuse me, u let's see here. Which of the following functions is also entire? Well, immediately we could knock out 2, because z is entire. Like, the function f of z is entire, but z bar is not entire. So that knocks out 2. So go back here and we do big fat that. Similarly, I think that also knocks out 1 as well. That knocks out 1 as well. Because that, yeah, actually, that's a good. If you consider f of z equals z, then this gives you z bar, that gives you z bar. These are not entire functions, so that knocks out this. But this gives you z. So I think it's this guy. We just need to show that. which is what I'm trying to do here. I will use a new page. This is an interesting question. This is just manipulation. It's not. This is just algebra. Mostly just algebra. It's a good warm-up question. So like, let g of z equal f z bar bar. The real part of that, what is the real part of that? Z is going to be x plus I y, g of x plus I y is going to be, let f just do everything out. Let this be u of xy plus I v of xy. This obeys Cauchy-Riemann. Let's see. This is going to be, what is this going to be? This is going to be u x minus y, all of this under a bar, plus I v x minus y, I think, because it's just minus, and then the bar is just going to be minus I, because this is entirely real now. Yep, I think that's good. Now, does this obey Cauchy-Riemann? We know f is such that ux equals vy, uy equals minus vx. Oh, I forgot. So this new one, I'm going to call it u hat, is going to be u hat xy equals, what is it, ux minus y, and v hat xy is going to be equal to, get a minus sign here, vx minus y. Given these two equations here, do we have, what is it going to be? Does this imply u hat x equals v hat y u? So we need to check these two equalities. This is just going to be a bunch of chain rule, I think. So partial with respect to x, u hat v y equals the partial, right? Let's see. And there's no dependence on y here, so that's just going to be ux. So ux equals ux. Partial with respect to y of u hat xy. That's going to pull in a minus sign. negative VY. Let's see here. I could just do this. Let's see. Yeah, I don't need to do all of this here. Vx hat, that's going to be a negative V X, because there's, and then Vy hat is just going to be a Vy, because these two cancel. I'm translating it over, we have U hat X goes to UX here, and VY hat is VY, so that, okay, we need to zoom out here. This is like our dictionary here. So we have okay, in this dictionary here. I don't know. Are people still with me? I'm just yapping. I tend to do that a lot. I will say the stream is mainly for myself because I have an exam on this in a bit, but I hope this is at least somewhat interesting. But basically, we're showing that the when you do the the transpose. No, conjugate, not transpose. Complex conjugate of this function on the inside, you still get a entire function because it still obeys the Cauchy-Riemann relations. And this is just applying the chain rule a bunch. It's like under these things. Let's see here. You get UX hat. Zoom out here so I can look at this later. U hat X equals UX equals by Cauchy-Riemann. VY equals VY hat. And then you have UY hat equals minus UY equals I think by Cauchy-Riemann this equals Vx. Yep. So I think that summarizes the proof. This is an interesting problem. Not too bad. Oh, I think someone else is live too. I might put peek over. There's a Summer of Math review-a-thon. That's fun. Cool. Okay. Back to more complex analysis. Where are you studying? I'm studying at a U.S. university. Just doing some complex analysis. Okay, that's a good question, I think. Okay, next question. We will show f of z equals z bar. Yeah, z bar is good. They call that z bar, yeah. Complex conjugate. I keep calling it transpose for some reason. Complex transpose is a different thing. It's like quantum mechanics stuff. This is not differentiable anywhere. Okay, we just use Cauchy-Riemann. F of z differentiable implies that the Cauchy-Riemann equations hold, yeah? Okay, let's not do that. Let's do this instead. Second. Okay. Let's write this in the form f of x plus iy equals x minus iy. Wait. Yeah, that's what that is. Cauchy-Riemann holds. That's u of xy, v of xy, ux equals vy, uy equals minus vx. Ux is going to be 1. Ux is going to be 1. Uy is going to be 0. Vy is going to be minus 1. Vx is going to be 0. 1 is never equal to minus 1. Therefore, never differentiable. Which is interesting. It's one of those things. Okay, that's enough about complex differentiation. We can do some complex integration now. So the f of z implies CR holds the only direction, or is it the other way? What is this? F of z is differentiable at a point z equals x plus iy, implies that the Cauchy-Riemann holds at that point. But we then we've shown, because you have only shown that Cauchy-Riemann, well, okay, Cauchy-Riemann never holds. But for f of z to be differentiable at a point, Cauchy-Riemann needs to hold, no? Okay, give me a second. I might actually just be completely wrong here. You have only shown that Cauchy-Riemann doesn't hold, which wouldn't be enough to say f of z is nowhere differentiable. No, let's see. The condition is if and only if. So there's like varying I think there's like Brown and Churchill and Brown, I think. Churchill and Brown is the textbook that's commonly used. But one of the formulations is if, like, because there's like a converse as well, where it's like there's like necessary and sufficient conditions, and I'll be honest with you, I keep getting them messed up. But like there is like one of the formulations is that if f is differentiable at a point, then the Cauchy-Riemann relations must hold. But it's not sufficient to say that the Cauchy-Riemann relations hold, then f is differentiable. Because you could have a situation where Cauchy-Riemann relations hold and f is actually not differentiable. Because you need some additional conditions on like continuity of the first derivatives or something like that. But it's enough to show that like if Cauchy-Riemann doesn't hold, then there's no way you're differentiable. Does that make any sense to the person who asked that? This is something that kind of, because I took complex analysis like with two different professors, and like it there was like two different formulations, and it was just like, okay, but like Cauchy-Riemann gets you like if you don't have Cauchy-Riemann, like there's no way it's differentiable. But like you need some other like continuity assumptions, which you normally have like when you're doing stuff. Like when you're doing analysis, you normally have like continuity assumptions. Like things are normally nice, but sometimes like when you're taking an exam, you can't assume things are continuous. That's like the one place you can't assume things are continuous when you're taking an exam. But yeah. Oh, good lord. Okay, let's do some. I need a spam. Not spam. What am I gonna say? Complex integration. Because this is the one thing I don't actually remember how to do. There's a list of integrals on here that I should know how to do. Let me just recall the Cauchy integral formula, because that might be helpful. So you have like this is actually like the one thing I remember the most, because I'm also going to I have to do like measure theory and functional analysis, which is like it's going to be a pain, but we'll get to it. Let's see here. So you have like a simply closed contour or something. Let's call it gamma. And f of z is analytic on and inside the contour, I think. Then, yeah, on and inside the contour. Then you have f of z, that's 0. Yeah, I think that's it. Then you have the Cauchy integral formula that says f of z over z minus a equals is like 2 pi I f of a or something, where this is like I'm not going to draw like axes every time, but like this is your a. Your contour goes like this. It's not clockwise. It's going to be positively oriented, so it's going to be counterclockwise. This is your gamma. And if that's your positively oriented contour, and I think if you're good enough, you can if you have sufficiently nice conditions, you have that. This is Cauchy's theorem. This is Cauchy integral formula. And then you have an extension of this where you can, let me add the TZs as well so I don't get yelled at. You can differentiate it inside. You get an n plus 1 here. You get f of z gamma dz 2 pi I n factorial f of a. I think I'm missing something, but I think that looks okay. I think there's like a minus 1 to the n or something, but that might be good. I'm not sure. Let me check my notes. There might be a -1 to the n plus 1. Ooh, that's completely wrong. Ooh. I got this part right. The n factorial's on top. 2 pi I. Your n factorial's on top. And similar analytic assumptions and stuff. So this is like the main one that people use. Okay. Let's see. Okay. Let's do some complex integrals. So these are going to be very important. Let's just bash some integrals. I may use the residue theorem. Don't really. I mean, the residue theorem makes things more convenient, but sometimes you can just get away with a Cauchy integral formula, especially if the integrals are simple enough. Okay, let's just go through this list of integrals. If we have time, we might go through some other ones. Okay, first one. Some of these are just going to be pattern matching the integral formula. Excuse me. Okay, so this is going to be sine z over z dz. Sine of z, I think, is analytic on the whole plane. We have this bad guy. That's a terrible circle. We'll ignore that for now. This is z minus 0, so it's going to be 2 pi I times sine of 0, I think. Let's just double check that. Here a is 0, 2 pi I times sine of 0. I think that's good. Sine of 0 is going to be, if I remember, that's 0. That's 0. Excuse me. I think that's good. I'm going to double check that because I am... Little Wolfram Alpha never hurt anybody. Integral of sine z over unit circle Okay, that's cool. Okay, ready for the next one. I can't. Okay, these lists of integrals are actually pretty not that bad. Sine of z over z minus 3 dz. Okay, here it's going to be the same thing, but 3 is going to be outside the contour. So it's just going to be like let's see here. If it's outside the contour, that doesn't really... I think this is just 0, because it's analytic. Everywhere and inside the contour, so this is going to be 0. Anyway. Yup, I think that's good. This is your circle, that's the only place where it's bad, so it just doesn't touch anything. Okay, this one is going to be a bit a pain in the butt. Z equals 2 sine z over... So here we have... something like that. That's 1, that's 3. The only thing that's gonna matter is gonna be like... Yeah, I could try the residue theorem. It's gonna be like the coefficient of the 1 over the residue. It's going to be 2 pi I times the residue of that guy, right? I'm less comfortable using the residue theorem. But if we just use partial fractions, it shouldn't be that bad. You could just use partial fractions and spam Cauchy integral formula. Because if you just use... do sine z times 1 over z minus 1. I don't know if you actually can do partial fractions on this guy. Let's see. It's going to be that part. Let's see. Let me actually... How the heck do I do this? I don't think you can do partial fractions. So I remember there's a way you could do this maybe with partial fractions, but... Because this part doesn't really matter for the integral, but... Yeah, me look at the book. This is where you use the residue theorem, the kind of I am looking up the book in another tab. Let's see here. Let's see here. Thought I had the textbook, but apparently not. Let's grab that. Integrals. Antiderivatives, functionist analytics, so we prove the theorems, etc. Cauchy integral formula, that's cool. What do we need here? Let's just use the residue theorem here. Let's see here. I know how to do multiplication of power series. I know how to do that. Because this integral here, I don't know if that's showing. That would equal 2 pi I times the residue at z equals 1 of sine z over z minus 1, z minus 3. I don't know how to calculate that guy. But that's the coefficient of the power series, right? At z equals 1. Let's see. I think, right, the Laurent series. You'd have to expand this guy as a power series. Like, it's 1 over z minus 1. You can make like a substitution or something. The residue is just the coefficient of the power series at like 1 over z of minus 1, but don't want to pull that like that hard, like that powerful of a tool out. There's a lot of dead air. Very cool. Okay. Let's get a new sheet of paper. See here. And the circle goes like this. So that's a bad point. That's gonna be 2 pi I times the residue. I don't want to calculate the residue though. The integral can be split into 2 smaller integrals. Oh, we don't have 2 poles though. We only have 1. Yep. Oh wait, no, you do. You treat. Oh my god. No, I remember. You treat like this is your f of z. That's your f of z. This is your z minus a. Then you okay. Yep. Okay. Yep. There we go. I got it. Times. This is gonna be evaluated at z equals 1, I think. So that equals, what is that? 2 pi I times sine of 1 over minus 2. Negative pi I times sine of 1. I'm going to check this with an AI tool. Okay, AI gives the same answer, so that's cool. That was a ride. I didn't even need Cauchy integral formula. That's cool. That took way too long, bro. Just skip ahead in the VOD if you're watching. Who's watching this VOD? Okay. Next integral. How about this again? We'll go for another hour or so. Integral along the same contour. Z squared, Z minus 3. Okay. Here you're really messed up. Here you're not so messed up. Right? 2, 3, 1. Something like that. Okay. It's n factorial over 2 pi I, right? Something like that. N factorial over 2 pi I. Okay. So we have this, so let that be g of z. So I think the final answer is going to be g prime of 1 factorial over 2 pi I times g prime of 0? I think. Because here what you have is you have the singularity squared, so that's n plus 1. So it's first derivative. That's 0 over 2 pi I. N factorial, that's 1 over z over a to the n plus 1. Yep. That matches. This is just, yeah, I think that works. G prime of 0 is going to, oh my god, this is going to be a pain. Let's just use product rule on this. At 0, that's 1 times. This is just a derivative calculation. Oh my god. 1 times minus 1 times minus 3 and minus 2. I think, I don't know. Let's check. Four ninths minus Hang on. Cauchy integral formula. Is 2 pi I. Oh. 1 over 2 pi I is normally here. So when it multiplies over here, let's give it 2 pi I. That's what, I was like, why is it on the bottom? It should be on top. So this should not be that. It should be 1 factorial times 2 pi I times g prime 0. Oh, this one. Okay. Give me a second. What do my notes say? My notes have something weird. They have n factorial over 2 pi I. So they have this integral f of z. I don't know if this is still on. The 2 pi I stays on top. N factorial over n factorial. Yeah, there we go. Good thing we got that ironed out. Oops. It should be right. 2 pi I over n factorial. Okay, let's try. Excuse me. Where's the n factorial multiplier? My notes. Excuse me. Oh, the nth derivative is n factorial over 2 pi I. But if you wanted to solve for the integral, it's 2 pi I over the n. Okay, that makes sense. Okay. That really stuck me up. Okay. Let's do this next one here. This. Can you still see that? Maybe. Boundary of a rectangle. 3 minus 1. 3, 7. Minus 1, 7. Oriented counterclockwise. What is that? What the heck? Call that f of z, f of z analytic, except where 1 minus e to the z equals 0. E to the z equals 1. Let z equal x plus iy. E to the x, e to the iy. Cosine x plus I sine y equals 1. Oh wait, no, there should be a y here. I sine y is no imaginary part, so sine y equals 0. Could let y equals 0. Cosine y is 1. Equals 0. Hence z equals 0. So that's the only bad point. That's really the only bad point. I think, right? Okay. So now we can just integrate around like a tiny circle. Isn't this just the residue? Yeah, it's just this equals 2 pi I times the residue. This guy equals 2 pi I times the residue. And this we could just do by like division or something. Power series. Let me actually do that. Put it on my end. 1 minus e to the z. Actually, let me find a couple terms of this guy and then multiply by z plus 1. That might be easier. One minus e to the z. Plus x squared over 2 that cancels. Minus x minus x squared over 2 minus x cubed over 6 minus something like this. Okay. And factor out a minus 1. These may be Bernoulli numbers or something, but I'm too tired right now to figure that out at the moment. I think there's also a way to do like 1 plus z squared plus z cubed plus z to the fourth. Because this is not just 1 over z. It's 1 over 1 minus z. That could stabilize pretty quickly. Actually, that might actually work. 1 minus f to the z equals 1 plus fz plus fz squared plus so on, right? So let f of z equal e to the z equals 1 plus x plus, or we'll switch to z now, z squared plus z cubed plus, with the appropriate coefficients, z cubed. It should work, no? Because it's all in the ring of formal power series or something. Actually, I don't think it works because this will get you like. Because when you divide by this, you get a leading x term, but here you don't, which is weird. Huh. Yeah, because I don't think it's ever... No, because e to the z is not less than 1. One minus e to the z equals x plus x squared over 2 plus... There's some issue with convergence or something. I can't be asked to do that right now. Long division time. One over x, you get 1 plus x over 2 plus what is this? X squared over 6. I think this is the minus 1/2. 1/2. plus x cubed over 24 plus I'm literally just dividing power series right now. I'm not like doing anything interesting. Maybe next time we'll do something interesting. Minus it's like 1 over x minus 1 over 2 plus O of x squared. And then you multiply this by z plus 1, x plus 1. I think you just get, because you only get a 1 over x like once, and that like this stays in the bottom with this 1. You don't get another one. So I think this is just 2 pi I equals 2 pi I times 1 equals 2 pi I. Well, let me check. I'm because I don't really want to divide any more power series right now. Wolfram alpha. This could actually calculate residues. Residue of at z equals 0, and then we could just do z plus 1 over 1 minus e to the z at. Oh, it's a minus 1. It's a minus 1. Why is there a minus 1? Oh, I dropped a minus sign somewhere. Because there's a minus here, and I didn't carry that through. So there should be a minus here. There should be a minus 1, a minus 2 pi I. Very cool, very cool. Ugh. That's enough. That's enough right now. I'll be completely honest with you. That's enough. I think I should be good, honestly. Unless what are other people doing? I will mute first. Okay, I'm gonna leave this VOD up, but I'm not gonna call it here. But hopefully do more streams in the future. But in the future, meaning like next couple days. But yeah, let's stop the stream here.